Hey guys, this is Professor Janacek. I want to talk about a convergence test. Want to look at the p-series test. Now, I'm a big fan of the p-series test. It's one of the easier ones to recognize. The p-series test always looks like the sum. The p-series always looks like the sum as k goes from 1 to infinity of 1 over k to the p. Turns out that this converges if p is greater than 1, and this diverges if p is less than or equal to 1. So all I have to do is figure out what p is, and then we know immediately if it converges or diverges. Let's jump right in and take a look at some examples. The first example, let's try the sum as k goes from 1 to infinity of 1 over the square root of k. All right, well, we all know that we can rewrite the square root as a 1/2 power, and there we have it, 1 over k to the 1/2 power. This is definitely p-series. In fact, in this case, our p is 1/2, which is very much less than 1, so that tells us that this series diverges. All right, that was pretty easy. Let's see if we can try another one. How about the sum as k goes from 1 to infinity of 1 over k to the 7th? Oh my goodness, couldn't get any easier. This one's absolutely p-series. In this case, our p-value is 7, which is very much greater than 1. So that tells us that this series diverges. This series converges. Now, I don't know what it converges to, but I do know that it converges. And that right now, that's all we're interested in. Okay, let's try maybe something a little more challenging. Maybe not. The sum as k goes from 1 to infinity of 1 over the cube root of 27k squared. All right, it's looking a little uglier, but we can handle it. Let's see here. There in the denominator, I know that the cube root of 27 is 3. The cube root of k squared, I can write that as k to the 2/3 power. Now that's looking pretty close, but not exactly like what I'm looking for. You'll remember that up here in the p-series, it has to have just 1 over k to the p. Can't have anything else there after the summation. So let's go ahead and factor out that 3 in the denominator, which makes it a coefficient of 1/3. And then we have 1 over k to the 2/3 power, which is definitely p-series. In this case, our p-value is 2/3, which is less than 1, which tells us that this diverges. Let's take a look at one more. Let's take the sum as k goes from 1 to infinity of 5 over k. Well, just like the previous example, we can factor out that 5. We have the 5 times the sum as k goes from 1 to infinity of 1 over k. The exponent on that k is 1, and there we have it. This is p-series. The p-value is 1. Well, equal to 1 tells me that it diverges. And that brings me to a very special kind of series. I want to specifically look at the series of 1 over k. Turns out that that is called a harmonic series. A harmonic series is a special form of the p-series. It also is the sum as k goes from 1 to infinity, but it's just 1 over k. Notice in this case, it's a p-series, where the p-value is always 1. Right? So p-series with p-value 1, we call it harmonic, and this always diverges. So, another cute little series there for you to have fun with. Enjoy.